Okay, we're going to look at another problem here. So we've got a description here. We've got a function that gives the amount of money in an account. You might recognize this function. We did this earlier in the semester, and you probably also did this in some kind of algebra class. It's a formula for interest compounded continuously with a $1,000 investment, 5% interest rate compounded continuously. So you might have to create that. In this case, they gave us that equation. T measured in years since the account was opened. And we are asked here to find the average amount of money in the account over the first 5 years. So I underlined this word here. This is especially important that you catch that's asking you for the average amount of money in the account over the first 5 years. So that you know how to do this. So this is really asking you about the average value of a function, average amount of money in the account, and that's what this function gives, is amount of money in the account. So you need to remember how to find the average value of a function. On an interval. So there is a formula, 1 over b minus a. This fraction out front is what a lot of students tend to forget. And then times the integral from a to b of the function, integrated from a to b of the function. Okay, so we can think about that. Also, just kind of making sense of it, we might think about the amount of money in the account at the start, the amount of money in the account 5 years later, and the average amount of money in the account should be somewhere between those, not exactly halfway between those, but somewhere between those two values. So we can look at this and easily see that there was $1,000 invested in the account, if you kind of remember back to those formulas. So I should expect my answer to be over 1,000, but not a huge amount, over 1,000. All right, so we are finding the average of this function, and our interval, it doesn't explicitly say that here, but it says we want over the first 5 years. So that would be from t equals 0 to t equals 5. So those would be our b and a values. And we're integrating a function, in this case not f of x, but this function, a of t. And so we'll be integrating with respect to t in this case, since that's our input variable. So for this function, the average amount in the account is going to be 1 over 5 minus 0, or 1/5, times the integral from 0 to 5 of our function, integrated with respect to t in this case, since that's our variable here. All right, so now I have to find the antiderivative and use fundamental theorem of calculus to find the value of this integral. So I might notice that I have this 1,000 coefficient here, which I can bring outside of the integral and divide by 5. So I'm going to go ahead and do that. So 1,000 over 5 reduces to 200. And now I need to find this antiderivative. So if this were just e to the t, the antiderivative of e to the t is just e to the t. But when I have this extra constant here, technically there's a little u substitution involved in doing that integral. So we did u substitutions earlier, and they've come up here and there in some of the problems we've been doing. But this is one that's going to require a u substitution because I have this extra constant in this function that's inside the basic exponential function. So we're going to let u equal that exponent. And then du is 0.05 dt. I don't have a 0.05 dt here. I just have the dt, so I'm going to divide by 0.05. All right, so in place of the dt, I'll be putting in du over 0.05. In place of the 0.05t, I'm going to be putting in u. And then the other thing that you have to be careful about is that these limits of integration are t values. So I need to convert those to u values as well. So when t is 0, u is going to be 0.05 times 0. So u is also 0. And when t is equal to 5, our other t value here, I have to figure out the u for that. So 0.05 times 5, so 0.25, 0.05 times 5. All right, so I'm going to write a new integral, so I do need to remember to substitute in for these as well, these two values here. Okay, so I will have 200, and then I'm going to have the integral from 0 to 0.25 e to the u, e to the u, e to the u. And then in place of dt, I have the du over 0.05. So just like I pulled this 1,000 outside the integral at the start, I can pull this 0.05 outside the integral, and that would be over 200. So I'll have 200 over 0.05. And then the integral of e to the u du is just e to the u. And I'm going to evaluate that from 0 to 0.25, 0.25. I'm having trouble writing today. Okay, so if you want to, you can go ahead and simplify this as well. So this turns at 200 divided by 0.05 turns out to be 4,000. So you could divide that out or just leave it as 200 over 0.05. And then I'll be putting in my upper limit of integration first. So I'll have e to the 0.25. And then minus this function evaluated at 0. Okay, so here is an answer in exact form. That doesn't tell you how much money is in the account. So especially in these applied problems, you probably want a decimal approximation rounded to something that makes sense for talking about amount of money in dollars, so 2 decimal places. So you're going to get your calculator out and plug that into your calculator. Don't forget to plug in this part as well. E to the 0 is 1, so this last term doesn't just go away. This is 4,000 times 1, or 4,000. And so when you put that in, 4,000 times e to the 0.25, then minus 4,000 times e to the 0, or minus 4,000, I get $1,136.10 approximately. So that makes sense. We started with $1,000 in the account, and then we didn't leave the investment for a super long time, so we shouldn't expect that it went up that much. We could figure out how much money is in the account at the end of 5 years, and then this number should be somewhere between those two values. Okay, try some homework problems.